Hi, everybody. We're going to get started here. If you don't know me or you don't recognize my voice, my name is Kevin Grenier. What we're going to cover today is Testlab Neo geometry. And you can still create geometry in classic Testlab, but we started adding geometry to Neo in version 2021.1. In January 2021, we had the import task, which we could use to import geometries from Testlab projects, CAD files, or CAE. And for CAD, we use STL files, stereolithography files. And from CAE, we can bring in Simcenter 3D, Nastran, ANSYS, and Abacus files. And then last summer, in July with 2021.2, we added the edit task. And there you could create standard geometries by creating nodes and then drawing lines, triangles, quads, derive degrees of freedom, as well as torsional disks. And then what we added this month with the 2206, which is the June 22 release, is the edit task. And there we can do auto wire. We can create automatically rectangles, prisms, circles, cylinders. And under the import task, we also have an automatic geometry reduction. So you could take a CAD file or a CAE file and reduce it from 20,000 nodes, 100,000 nodes down to a more manageable number for testing, 100 or 200, for example. And then rather than drawing lines and elements on it, you could just auto wire it automatically. So I'll show all that today. So in Neo, we're trying to redefine test geometry creation process. It's a way to easily create and manage multiple geometries in a single project. So rather than just having a single geometry, we can have multiple. You can choose which one is the active geometry, and then you're allowed to edit the active geometry. And if you go to display any modes or operating deflection shapes, those will operate on the active geometry. And then there's going to be dedicated tasks for importing or editing, creating these geometries. Like I said, you can create standard geometry components, just like you can in Classic. There's also this interactive reduction of your finite element or your CAD files. There's also mode shape reduction included, so I'll show that as well. So if you're reducing a large finite element model down to a smaller number of nodes, you can reduce the mode shape with it. And then any geometry you create in Testlab Neo, you can use in Testlab Classic as well. The projects go back and forth between the two without any issue. On the import task, basically, if you look at the geometry task, there's an edit task and an import task. An edit is used for basically editing an existing geometry or creating new nodes, lines, surfaces, things like that. And then under import, it's really used for importing from existing geometries, either from CAE or CAD or even a Testlab project. You can preview them, so there's a quick preview before you import them. And then you can either interactively create the wireframe, or you can use the automatic reduction to do it automatically. And I'll show both. Under the edit task, this is a dedicated task to create and modify the geometries. The focus is on the geometry in the open project. There's basically one table per geometry element. So you'll see, we can see a nodes table. We'll see an elements table that'll show the lines, triangles, and quadrilaterals. There'll be a derived DOFs table that looks at the derived degrees of freedom. And there's a disk table to look at the torsional disks. You can also import, export CSV, so I'll show that. And then under the edit add ribbon, there's a tool to auto wire, as well as create rectangles, prisms, circles, and cylinders. And there's also a really great undo and redo. So basically, I could go ahead and delete a component, and that's going to delete the nodes, the lines, and the surfaces. But then if I hit undo, it brings everything back. So it seems to work really well. So that's really all the slides I show. I'll have some wrap-up ones at the end, but I'm going to jump right into Testlab. So here I'm in Testlab Neo, and under add-ins, I've turned on the geometry creation add-in. So it's 16 tokens, which is the same geometry add-in that would use in Classic. So if you have tokens, you can open it. Or if you have geometry license in Classic Testlab, you can use it here in Neo as well. Same licenses go back and forth between Classic Testlab and Neo Testlab. And then if I go to this geometry worksheet, I can see these two tasks. I have an edit task and I have an import task. So if I go to the edit task, I'm going to create a new component. So if I expand my project here, expand my geometry, say new components. So it looks like I have two components now. So I'm going to call this first one, I'm going to import, I got to do it. Okay. So now I can rename this one. So I'm going to call this cube one. I'm going to give it a different color. And let's call it red. Okay. And I don't need this component two. I'm going to delete that. So I can either right click and delete, or I can find delete or rename in the organize ribbon. So I'm going to delete that one. Okay. So now I'm going to work with this cube one. I can go to the nodes table and I can click add row a few times. So I'm going to add 8 rows here. And I'm just going to make a simple cube. So I'll do 1, 1, 1, 1 like this. And then I can copy this and I can paste here. Okay, and then I need to move these up, I think, in Z. Okay, so there I have my 4 nodes created. I could export and import. So we had people complain like, oh, why do I have to hit row every time? Well, I can go to import and I can create files ahead of time. So this is like 50 blank nodes, 100 blank nodes. So once you see the syntax of that CSV file, you can import those to get a bunch of blank nodes, or you can pre-populate those CSV files with the actual node numbers and positions if you want. And now that I've had these nodes here, I can go down to add and I can start adding lines. You won't see the lines until you move to the elements table. Now I can see the elements table. So here's the nodes table, and this is the elements table. So I can just go ahead and start drawing lines. If I say add, and I can draw lines. Get the wrong node there. I'll have to delete that line, so I'll show you how I can delete lines later. And then if you need to zoom, I can zoom. I can rotate, all the same standard stuff. Okay, so if I want to delete this line, that's kind of a bad line here, I can pick it. I just stop drawing. And then I can pick this line, and then I can delete it. And I can either use the delete, or I can right click on that row in the node table and hit delete. So if I want to start drawing lines again, I just click add again, and I'm drawing lines, and I can complete this little cube. Then you break a line by hitting that node a second time, so you can start drawing somewhere else. The same as classic Testlab there, and looks like I missed a line. So that's how we draw lines. If you want to draw quads, I can stop drawing my lines, go to quads. You're still in the element table, and then I can say add, and then I can collect 4 nodes. So let me zoom here, and then I can go ahead and complete this cube. Okay, I had a couple of cups of coffee today, and I'm shaking. But you guys get the idea. I guess I could have just imported it. Looks like I got a couple surfaces left. And then what you can see, it's kind of not red while I'm drawing it, so it's going to be either kind of white color or it's going to be green if I select a surface or select a line or anything like that. But then once I'm all done drawing, everything will be red. But now it's kind of a color whether it's selected or unselected. Okay, so finally, there's my cube. Okay, so now I'm done drawing, I can hit stop. So I can either add lines, triangles, quads, derived degrees of freedom, or disks. If I look at the node table, one thing I forgot to show was an Euler angle. So if I wanted to, I can specify my Euler angles here and maybe turn on my node names as well. And maybe I want to put an Euler angle here at a cube 5. So I'm going to go to cube 5, and maybe I'm going to do a rotation about the z-axis. So that's going to be maybe 45 degrees in the xy here. Okay, so then you can see this Euler angle has been rotated. And I can either change the Euler angle in the node table, or when I highlight anything on that row, on the right side, I see the properties of that node, and I can change it there as well. So I can go back to 0 if I wish. Okay, so we can either do the Euler angles in the table, or we can do it by picking a node and then looking at its properties on the right side, and we can change it there. So now I have cube 1. So maybe I want to duplicate cube 1. So I can right click and I can say duplicate. or I can look for a duplicate in the organized ribbon and I can duplicate it. So now I have cube 2, and if I fit model here, looks like they're on top of each other. So what I can do is I can look at cube 2, I can change its color, and then I can see its position here. So maybe I want to move it 2 meters in the Y. So now I can go ahead and fit model again. So now I've got cube 1 and cube 2. And then if I highlight cube 1, I can see which component is active by picking them. And now if I wanted to draw lines between these two, I can say add lines. And then I can draw my lines between cube 1 and cube 2. And the only reason I'm going to do that is to show you how it differs depending on what you highlight inside that little navigator tree. So now if I look at cube 1, I can see the nodes and the elements on cube 1. If I look at cube 2, I can see the nodes and elements on cube 2. But I don't see the lines between cube 1 and cube 2. If I go to the geometry, then I start to see everything. So the geometry will show you the lines and elements on all components and also between the components. Or you can see them per component by just having each component as shown here. Okay, and then I wanted to show the export. So if I go to nodes here and I'm on cube 2, I'm going to export to CSV, call it node Thursday. Hit save. Then I can go to the elements table. I can export the elements here, call it element Thursday. Okay. Okay, so I showed duplicating a component, but I could also create new ones. We'll call this one cube 3. It's not probably. Then call it cube 3. Then I can change the color if I want it to be blue, maybe. Okay. And then under cube 3, I can look at its nodes, and I can import the CSV nodes. Okay. So it brings them in, and I can go to the element table, and I can import and bring the elements in. And now I can shift it if I need to. So shift, then maybe I want to shift it by 4 meters in line. And now if I fit model, then I see all 3 cubes. Okay, so I can duplicate components, and then after I duplicate a component, I can always move them by changing the position of the origin, or I can also rotate them by changing these component order angles. Or I can always export my nodes and elements, create a new component, and then import them back in. And then again, if you needed to edit those CSV files, you could edit them in Excel, and then modify them and bring them back. I haven't talked about derived degrees of freedom yet. So if I look at the derived DOFs table, and I'm going to add a degree derived DOF, so I hit add. And maybe I want cube 3.7 to follow cube 3.8 and cube 3.3, and then say add. Oop, I forgot to pick it first. So let me do that again. I want this guy to move like this one, and this one, and I'm going to do it in XYZ. And say add. Okay, so there it is. So again, I had to figure out which component I was on. I had cube, I didn't see it. Cube 1, I don't see it. If I would have been on cube 3, I would have seen it. Or I can go to geometry and I'd see it there as well. And now I can see if I stop drawing, I can change it. So maybe I didn't want it in Y, I could turn it on. So these are nice if you wanted to animate and perhaps cube 3 node 7 had an issue and you wanted it to act as a weighted average of 1 to 4 nodes. So you can have 1 derived degree of freedom, and you can have it follow up to 4 main nodes. If you wanted to see another one, I can hit add. I can pick this point, and it turned blue. Maybe I want to pick up to 4 main ones, to pick them all, turn on the degrees of freedom you want, and hit add. And then when you're done, you can hit stop. And then once you stop, you can turn off the degrees of freedom if you want. So now you can see these. Oh, looks like I forgot to pick a node. So one of them is going to follow 2 nodes. One of them is going to follow 3 nodes. I can also create torsional disks. So if I go to disks and say add, and say adding a disk, and hit add, and maybe I want a torsional disk here. Maybe I want it in the Y direction. Pick that node again, and then say add. And maybe I want one here, and say add. Okay, so I've got two of them. I can hit stop, and if I want, I can change the radius. Maybe I want this one to be 0.5. Okay, so then if you had a torsional displacement, velocity, or acceleration, I could animate that, and then you would see these disks shift. So perhaps if you had like a shaft, and you wanted to see twisting along that shaft, you could have torsional transducer on either end of that shaft, and then we could see it animate and shift, and you would see these radius lines move based on the torsional velocities. Okay, and then if I wanted to, I can look at cube 1 here. I didn't show the list nodes button, so there's a list nodes button, so I can look at the nodes on cube 1. If I go to the geometry here, I can list nodes, and I can get the nodes on the entire geometry. If I wanted to delete some things, you want to look at these elements here, and then I can either start picking elements with my shift, like this. If you look through, you can see which ones are highlighted, or I can use my mouse and draw rubber band like that, and then it'll pre-select everything. And then I can hit delete. They're gone. If you don't like that, I should be able to undo. Here's my undo, and then I'll come back. If I go to nodes here, and if I go to delete all these nodes, all the nodes are going to disappear, and all the lines and all the quadrilaterals and the disks, everything will disappear. So I can delete. You get this nasty warning that everything's going to be removed, and then I can undo, and everything comes back. So it seems to be a really smart undo redo button. And even though you get this nasty warning, if I go ahead and delete again, they're not actually permanently deleted. They do come back. Okay, so that's basically standard geometry creation. So now I'm going to create another geometry. So I can go new geometry here, and then geometry 2 here. Maybe I want to call it standard shapes. And then if you have nodes on the geometry that aren't tied to a component, you can change the color here, which is nice. So you can change the color of the geometry if you've got nodes without a component, and then you can also change the color of each component. And then up at the top, it's kind of hard to see, but there's actually the active geometry pull down. So we have an active section pull down, and we also have an active geometry. So if you're trying to edit a geometry, you want to make sure it's the active one. So for example, since standard shapes is here, now I go to my cube here and try to delete stuff, and delete is grayed out, and I can't right click and delete either, and it's because it's not the active geometry. So if I were to make geometry 1 my active geometry, now the delete comes back. That's the FYI. So now I'm into standard shapes geometry, and then I'm going to go to the add ribbon. So here I'm on the edit task, and up at the top I can go to the add ribbon, and I can see rectangle, prism, circle, cylinder. So I'm going to go to my standard shapes geometry here, and I'm going to add a rectangle and give it a name, rectangle 1. And then you pick where you want your origin, center or corner. You pick the plane you want it in. Some options for picking the coordinate system based on the global XYZ. Or if you had a node with an Euler angle, you could pick that node to get the coordinate system. And then you pick a length, number of nodes across that length. You pick a width, maybe a number of nodes along that width. And then you turn on meshing, you turn on create lines, you turn on create surfaces, and pick how you want your coordinate system. And hit OK, and there it is. If you don't like it, if you made a mistake, I can go to undo, it's gone. Go back to rectangle, and maybe I want only 2 here. And then I can give it a name and hit OK. Okay, so that looks bad, but that's how you do rectangles. If you want, you can see the Euler angles. If you don't like the Euler angles, you can always change them. So again, I can add Euler angles here on any node, or I can do it in the properties of that node. And then if I wanted to put it on a different plane, so let me undo this guy and hit a new rectangle. And then put it in a different plane. So maybe I'm going to put it in the YZ plane. Then I'm going to go back to 4 nodes along here. Okay. And now you can see it's put it in the YZ plane, but it added Euler angles everywhere so that Z is always normal to the surface. And if you like that, that's great. If you don't like that, and that kind of bothered me a little bit, I didn't like that. So what you can do is I can get rid of all these Euler angles here. If I copy this guy and copy to this row and paste. Oh, it looks like a copy and paste. Okay, I can start getting rid of all these Euler angles. So if you don't like the Euler angles, you don't need to keep them. And then now I've got my Euler angles in global XYZ rather than being created when I created that rectangle. That's up to you. Let's see if I can undo that. I can. Okay, so there are the Euler angles as created. And by default, if you're making a rectangle, it's going to put the Z direction always normal to the rectangle. That's the default behavior. Okay. If I don't like this, I can delete this component. And then I'll go on to prisms. So a prism is basically a cube, but it can have a different top and bottom. So a different area, top and bottom. So maybe I wanted to have it to be, again, build it in XY. And maybe I want it to be 10. And I want to have 10 nodes along the length. And then maybe I want the width to be 2. And I want maybe 4 here. Oh, I guess the height is where I want the 10. Let me do it that way. And then we'll call this 4. Okay, and again, I can tell it to mesh and create my lines and create my surfaces. So there's my cube. And now I can go ahead and hit fit. Okay, so there's my prism. So a real quick way to make a box. If I want, I can undo that. And then I can show circles. So I can call it circle 1. And then I can specify a radius, specify circular mesh. So these are the points around the radius. Pick length along the radial mesh. I'll leave it at 1 for now. And I can turn a node in the center or turn that off. So I can hit OK. So that's what it looks like. So there's my circle. Let me fit model. So if I do another one, we call it circle 2. And now I'm going to turn on the node in the center so you can see what that looks like. So that's what that looks like, node in the center. And then if I do another circle and call it circle 3, and then I'm going to turn node in the center off. And then maybe I have radial mesh 2 here and see what that looks like. And then I can separate these. So circle 2, maybe I'm going to move this 2 meters in Y. Maybe circle 3, I'll move it 4 meters in Y. And then if I fit model. So you can see the behavior. Okay, so the first one on the top left is no node in the center and only 1 node along the radius. The middle is 1 node along the radius, but I added the center point. And the third one is 2 nodes around the radius, but I don't have a point at the center. So this would be a quick way to make a break rotor, perhaps. So that's the circles. If I want, I could also do a cylinder. If I do a cylinder here, I'll call it cylinder. Again, pick your plane. Pick the radius, 1. Pick the height. Maybe I want this to be 10. Maybe I want 8 points around the perimeter. And then I can turn off add nodes in the center and hit OK and see what it looks like. Okay, so I didn't like that, so I needed to change how many nodes I have along the axis. I'm going to undo that, put it back in. And then I'm going to have maybe 10 along here. That looks better. Okay, so now it's again created it such that X is always normal to the surface here. And I've got cylindrical coordinate systems created. So those are the standard tools. So we can create rectangles quickly, create prisms quickly, circles, and cylinders. Okay, so now I'm going to show the import task. So this is basically the edit task. So under the edit home ribbon, this is basically for creating nodes, elements manually, along with derived DOFs and disks. And then if you go to the add part of the ribbon, here we can rectangle, prism, circle, and cylinder. I'm going to show AutoWire in a few minutes. And then if I go to edit import, I can basically browse to existing geometries. So I've got a quick access folder here I can go to, where I've got a bunch of different file types. So if I come here into this Nastran PDF file, there's a Nastran file of a flat plate. Here's one of a Boeing model. So this is a Nastran file. Here is a Abacus file. So this one's a little bit bigger. I think it's 100,000 nodes. And I can look at it. Okay, so now that it shows you on the left display, this is a preview, and the right side is the active geometry. So I'm going to make a brand new geometry here. Okay, so now I got a brand new geometry. It's called Geometry 2, I believe. And now I can import. Maybe I want to import something. Here's another plain Nastran file. Okay, so this is a smaller CAE model. I think if I list the nodes here, this one has about 400 nodes, it looks like, 425. Okay, so I can import that. I'm going to create a brand new geometry. So this is now geometry, it looks like. And I'm going to change the name. And maybe I want this to be a plain CAE. I spell it right. Okay. And then one of these other geometries should be blank. So this geometry 2 is blank. So I'm going to rename that one. And I'm going to call it plain test. Okay. What I'm going to do now is pick nodes from this geometry here. So basically, I can go into the import task and then click on this pick nodes button. Let me give myself a little bit more real estate here. And I can start picking nodes. And when you start picking nodes, you can either draw nodes or draw the lines or not. So I'm going to turn on connect the nodes here. And now I can start picking nodes directly from my CAE model. And I need to make sure my active geometry is a test one. There it is. And I'm going to start drawing my nodes again. And basically what it's going to do is it's going to pick nodes from the CAE model and start adding them to my active geometry. So if I click model over here, so I only picked one node. There it goes. Okay, so now I've picked 3 nodes and it's starting to draw lines between them. So you can see how it goes. So I can do this and pick nodes directly from my CAE model. And this is what was available in Testlab 2021.2. And if you want to do this, this works okay. It's a little clunky because if I wanted to basically close a line, so let's say if I wanted to come over here, and now let's say I wanted to complete this line over here, when I pick this node 152, it's going to turn it off. So it's not ideal. So you could pick most of the nodes you want, draw a lot of the lines, but then when you're done, you'd want to go back and stop it, go to edit, and then go to elements and start adding more lines to kind of close up the structure. Okay, so that was the way we did it in 2021.2. If I go back to this import task, and let me delete these nodes first. Let me go back to edit and nodes, and let me delete these nodes here. So now I'm starting with an empty geometry. And if I go back to import, I can go back to this plain geometry, and either through right click, I can go to automatic reduction, or if I go into the toolbar underneath the organized geometry ribbon, I can see automatic reduction. And this, looks like I'm going to give it a new name, so I can call it plain test 2. So I guess I didn't need to delete the other one. And then I can tell it maximum number of nodes. And I started with 400, so let's say I want to go down to 100. And then you can tell it the minimum distance between nodes. If you wanted, you can pick a symmetry plane. And then if I had modes in here, and it looks like I do, I can tell it to reduce my modes as well. And I can find the modes either from my same source file of my geometry, or I could have them in the input basket. So now I can say, OK. So now I created that reduced geometry. So if I look under plane, it looks like I created it as geometry. Nope, plane test 2, I called it. And if I list the nodes here, looks like it reduced from 400 down to 100 nodes. And then it's keeping the original node number. And that's important because if you want to do a MAC between your CAA modes, your finite element modes, and your test modes inside Testlab, the nodes have to be exactly the same name. So by doing an automatic reduction from your finite element model down, or by manually picking the nodes from the finite element model, you're making sure that the test nodes have exactly the same DOF ID as the CAE ones. And that way we can do a MAC from the test and the CAE very easily. So here I quickly reduced my 400-point finite element model down to 100. And then if I look at my desktop, and if I look at my project here, I can see here, these are the reduced mode set I created. So each of these modes here, if I look at one of them, I guess maybe I can't see the number of degrees of freedom here. But it has 100, oh, it should have 100 nodes. No, that's 100%. But it is a reduced element. If you wanted to compare the CAE, I could open up a 2x2 picture here, or a 1x2 that has 2 geometries. So here's my 2 geometries. So here on the left side is my test one. And I don't have lines on it right now, so I have to show my markers. So there's my test geometry. And if I go back to my OP2 file, with my plane here, and I'm on mode 2. Okay, so there I'm looking at my reduced finite element model on the left, and I'm looking at my finite element model directly on the right. If I wanted to auto-wire this geometry, I can go back to geometry here, and then make sure it's the active geometry, and it is. And then I can go to the edit task. I can go to add, and I can tell it to auto-wire. And then I can tell it to use all the nodes or selected nodes. And I can specify the max angle between degrees. Now let me turn my other angles off here so you can see it. As you can see, I don't have any nodes there. And then maximum number of wires per node and the maximum distance between the two. And then let's start with 1 here. And then it's going to miss some. So I can hit apply. You can see that it missed some. And then if I don't like that, I can change this to a different one and apply. And now it's closed up that geometry a little bit. So AutoWire is also available to you now. So basically, rather than picking the nodes manually from the finite element model and drawing the lines, you can pick a finite element model, tell it to automatically reduce it, then come here to AutoWire it. Okay, so let's pick a geometry that's perhaps larger than 400 nodes. So here I've got this scale model of a Boeing plane, and this one has, I list the nodes here. So this one has about 20,000 nodes. So maybe I want to automatically reduce it, and let's call it. And maybe I want to go down to maybe 200 points, maybe 500. And then pick your minimum distance, 50 millimeters. I can pick a symmetry plane, and I'm not going to reduce the modes here. I could, but I'm not going to. Maybe, I guess maybe I will. Hit OK. Okay, so there is my reduced. And then it's a little bit coarse. So if I were to try it again, maybe I need to have this to be a little smaller. Okay, so that's a little bit better. Okay, so now if I wanted to auto wire this, I could go back to my edit task, then go back to my add, and let's say I want to auto wire this. Use all nodes, pick the min angle between wires, maximum number of wires per node, so basically maximum number of elements per node, and then the max distance ratio, hit apply, close, and you can start to see it wired. And if I want, I can turn off the node markers if you don't want to see them. Okay, so it's not perfect. So I could probably tweak that to make it look a lot better. But it does do the auto wire for you. You just have to tweak the settings a little bit. And if I wanted to, I can go back to the desktop, go back to my 2x2 geometry display, and go back to my project. These are the Boeing ones. So these are the modes that I reduced. Doesn't like to replace the geometry. Let me open a new picture then. 2x2 geometry. And I can put that in a new display. Okay, so there it is. If I wanted to, I could go look for the original one. This was the Boeing OP2 file. And this was what, 12 hertz? Okay, there they are side by side. If you wanted to try a larger file, I can go back to geometry just to show you it does work with a little bit larger files. And go to my import. Which one's big? I think this crank one is pretty big. So if I list the nodes here, it'll take a little bit. I think it's 100,000 nodes if I remember right. I didn't see the nodes pop up, but okay, there. Yeah, so it's 106,000 nodes. So if I wanted to reduce this one, so go to automatic reduction. I give it a name. Then pick a maximum number of nodes, pick the min distance. I'm not going to reduce the nodes here. I actually did have them, but I'm not going to reduce them here. And then fit model. Okay, so there they are. And then if I wanted to see how many nodes it reduced it down to, I can go to my crank here, list the nodes, and I asked for 500. It looks like I got 500. And again, I could auto wire this if I want. So I'm going to show a couple other things real quick, but just as a wrap up, under the geometry import tab, we can import any geometry we can browse to. So basically, Testlab supports universal files, Testlab projects, ANSYS, Nastran, and Abacus. And then I can either manually pick nodes and have it draw lines, which is a little bit cumbersome, or I could do an automatic reduction and then do an auto wire automatically. Under the edit task, I can manually create nodes and elements and draw DOFs and disks. Or if I went to the add, I can do standard shapes, rectangles, prisms, circles, cylinders, and I can auto wire my mesh. And the auto wire doesn't have to be from CIE. Maybe I wanted to type in my nodes manually, but I don't want to make my lines myself. I can go to auto wire and automatically create the lines automatically. Okay, well, thank you, everybody. Thanks for your attention. Everybody have a great day.